This is Mr. Mac from Acesmath. Okay, so today I'm bringing you one of the questions that you always see in your application of differentiation, okay, where you involve the use of parametric equations in the front part. So usually you will see this kind of question at the very last part. Okay, so and before we go into the question itself, so let me share with you some of the things that I guess most of our students have issues with. Okay, so if you notice in this case, in a parametric equation, all right, so typically when you have a x equals to maybe 2t and your y equals maybe t squared plus 1. Okay, so what I need you to see, and I hope to share with you here, is actually the equivalent form if you write them in the coordinate system here, was the fact that you can actually write them as your x coordinate will always be written as 2t, while your y coordinate is written as a t squared plus 1. So if you notice, so actually in this case, if you notice that your x and y coordinates is controlled by a third variable, a third parameter here, t. Okay, so it's actually a form of your parametric equation. Okay, so if you go back to this question, okay, given that point A is 2 sine theta, 0, point B, okay, by the way, this is part of the question, so usually you'll see at the last part, okay, so point B here is 0, 2, so cosine theta, and point D is the midpoint of AB, okay, so this is the part. Okay, find the Cartesian equation of the curve traced by D as theta varies and identify the shape of the curve. Alright, so let's take a look at this. Okay, first of all, probably some of your EMAth content here, you want to talk about the midpoint of your D here. So you basically do a x1 plus x2 over 2. So you have a 2 sine theta over 2. Then you had a 2 cos theta over 2. Okay, so if you simplify this, your x coordinate is sine theta and your y coordinate is cosine theta. Okay, so here in this case, okay, so we are looking at the midpoint of D, whereby D, the x and y coordinate, is actually traced out by theta that's changing. So here, okay, this is the part whereby just now when we were recapping, okay, so this is where you need to see that once your x and y coordinate is controlled by a third parameter, so this is actually a form of your parametric equation. Okay, so this question actually becomes more like a situation whereby you're changing from a parametric equation into a Cartesian equation. A Cartesian equation mainly is just an equation involving purely x and y. Okay, so just to share with you some tricks here. So in this case, if you are looking at your x and y that is in parametric form, controlled by trigo, okay, and sine and cosine in this case. Okay, so you can try to activate some of your previous knowledge about your trigonometric identity. And in this situation, okay, what you can see in this case, okay, so this part here, you need to recall that your sine square theta plus cos square theta is equals to 1. And because of that, you can actually just substitute in your x and y. So this is x square plus y square equals to 1. And so with that, you actually have converted it into a Cartesian form. Okay, so we are done with the first part. Okay, then and also identify the shape of the curve. So if you realize this is in your usually your J1 topics on your conics, this is a unit circle. Okay, the radius is 1, centered at the origin. Okay, so if you're not sure about this, please go and recall about it. All right, so I hope I've shared with you some tips and some misunderstanding. Okay, if you like this, please follow us and share these videos with your friends. Thank you.